Hello teacher and my friends. We will talk about endoscopy capsule. Today our learning objectives are history of endoscopy, what is capsule endoscopy and its history, inside the capsule, how does capsule endoscopy work, uses of capsule endoscopy, advantages and disadvantages, and finally, future of capsule endoscopy. First of all, I'm going to talk about what is capsule endoscopy, its history, and a little bit of structure of capsule. But before talking about capsule endoscopy, it is necessary to talk about the history of endoscopy. The first endoscope was developed in 1806 by Philip Mozzini in Mainz with its introduction of Lichtleiter. It means in English light conductor, for the examination of canals and cavities of human body. The first use of endoscope in successful operation was Antonin Jean de Zermo, whose invention was the state of art before the invention of electricity. Adolf Kussmaul, in 1868, used a straight rigid metal tube over a flexible obturator to perform the first gastroscopy. Rudolf Schindler constructed the first practical gastroscope in 1932. Basil Hirschowitz and Larry Curtis invented the first fiber optic endoscope in 1957. Traditional endoscopy has evolved over years, but has not been enough to find the diagnosis of disease of the small and large intestine. Reaching and examining that organ with the traditional endoscopy method was impossible for both patients and doctors. Capsule endoscopy has come as an invention that facilitates these situations. What is capsule endoscopy? Capsule endoscopy lets the doctor examine the gastrointestinal tract, which includes the three portions of the small intestine. Those are duodenum, jejunum, ileum. Doctor will give a pill-sized video camera for a patient to swallow. This camera has its own light source and takes pictures of small intestine as it passes through. These pictures are sent to a small recording device that patients have to wear on his body. Why is capsule endoscopy done? Capsule endoscopy helps doctor to evaluate the small intestine. The part of the bowel cannot be reached by traditional upper endoscopy or by colonoscopy. The most common reason for doing capsule endoscopy is to search for a cause for bleeding from the small intestine. Capsule endoscopy can be applied in the patients that have esophagus and colon disease. Easy to apply, complications of low, high efficiency, a technological diagnosis method. It magnifies the image by 8 times, resulting in larger and clearer images than standard endoscopes. During the procedure, the intestines are natural and the capsule acts passively. Recently, capsules that can take images from both ends of the examination of the colon and esophagus have been started to be used frequently in daily practice. Let's turn to the capsule endoscopy's history. The diagnostic pill was invented in 1990s by Israeli inventor Gavril Idun. Gavril Idun was an electrical engineer who previously worked at Israeli military manufacturer Rafael Israeli's Armament Development Authority, developing guided missile technology. Gavril Idun's first capsule endoscopy product was named M2A capsule and was cleared by the FDA for a small intestine visualization in August 2011. PillCam has had tremendous success after its release in 2001 because of its improved safety and accuracy. It's more healthier than X-rays and radioactive tracing of stomach tumors. Currently, the PillCam video capsule has been used approximately 1.5 million times by more than 5,000 medical facilities in more than 75 countries. Now let's talk about the structure of capsule. The device used in capsule endoscopy is 25 mm long. The outer shell is made up by biocompatible material. As it's very small in length, it can be swallowed vertically. Its diameter about 10 mm, very much less than the length of it. It helps us to swallow easily and it can travel through our esophagus and easily because of its structure. It looks like a small tube. Now we have a video for better understanding. Let's watch.
The small intestine is part of the gastrointestinal tract, the GI tract. It is approximately 20 feet long and is the site where most digestion takes place. A standard endoscope may be used to examine abnormalities of the small intestine, such as tumors and bleeding. However, these endoscopes may only reach the first 3 to 6 feet of the bowel. Oftentimes, the abnormality is located in the remaining small bowel. But with video capsule endoscopy, doctors can examine hard-to-reach tumors or view distant intestinal bleeding through dynamic video taken of the bowel. Video capsule endoscopy is a non-invasive procedure where a computerized capsule is used to view the entire length of the small intestine. The capsule is about the size of a vitamin and contains a transmitter, a battery, a color video camera, and an LED light source. The capsule is sealed and resistant to stomach acid and digestive enzymes. The pill takes 2 pictures per second as it travels via muscle contractions along the GI tract. Distant sites in the tract may reveal a tumor or bleeding from the intestinal wall, which can be more accurately identified. Sensors on the patient's abdomen send these images to a receiver worn on the waist. After 8 hours and over 50,000 images, the sensors and receiver are removed. The images can then be downloaded to a computer where they are viewed as a video and examined by a doctor. The capsule is not reusable, and many people do not realize they have passed the capsule when it is eventually excreted with waste. Detailed dietary instructions are given to the patient prior to this procedure. It is important to avoid areas with strong magnetic fields and to discuss potential complications with your doctor.
Hi, I will talk about the inside of the capsule. Capsule endoscopy has 8 parts. These parts: optical dome, lens holder, lens, illuminating leds, CMOS image sensor, battery, ASIC transmitter, and antenna. Optical dome. Optical dome is a non-conductive element of the capsule and represents the front of the capsule shape. Its functions involve liquid filtration and other enzymes balancing. Optical dome is on front part of the capsule and it is pallet shaped. It is also light receiving window. Optical dome is harmless and it has ability of easy orientation and easy propelling. Second part is lens holder. As the name implies, it holds the lens firmly to the capsule to prevent detachment. Lens holder accommodates the lens and avoids dislocation of lens, so lens is tightly fixed. Lens. The lens is the eye of the capsule and can't be underestimated. It forms one of the major parts of the capsule and it plays on the side of the optical dome. Lens is integral component and it is on behind light receiving window. Light raw windows falls on the lens. Illuminating LEDs. There are several components that make up of the LED, and the aim of it is to illuminate light around the passage region of the body for easy identification of affected tissues. LEDs prevent reflection through the light receiving window. LEDs are present around the lens and CMOS sensor. There are 6 LEDs on the capsule. These lighting devices are arranged in garnet shape. CMOS sensor. This is the beauty of the capsule because in minutes it detects objects as less than 0.2 mm and work on precision of 172 degrees. CMOS sensor can detect objects as small as 0.1 mm and it is precise. With CMOS sensor, capsule endoscopy can detect a polyp, but traditional endoscope can't do that. Battery. The design nature of the battery may be harmless to the body because it is made up of silver oxide. It is to make it last for the period of examination and has a button shape. Batteries are button shaped and there are 2 batteries in the capsule. They have equal discharge voltage. Batteries are disposable and harmless. ASIC transmitter. The transmitter has two electrodes isolated electronically and is an integrated circuit which helps the facilitation of image captured. Transmitter is an application of specific integrated circuit. Transmitter is on behind the batteries. Two transmitting electrodes are connected to it. Electrodes are electrically isolated. ASIC structure that includes a clock management module, a power-efficient image compression module, and a power management unit. An ASIC-based prototype capsule, which measures 11 mm times 25 mm, has been developed here. Test results show that the designed ASIC consumes much less power than most of the other VCA systems, and that its total power consumption per frame is the least. Last part is antenna. The communication existing between the belt receiver and the capsule is done by the help of the antenna, which is coated polyethylene. Dome of antenna is harmless. In the antenna, parylene coated onto polyethylene or polypropylene is used. Antenna receives data from ASIC transmitter and sent to data recorder.
In this part of our presentation, I'm going to talk about CCD and GMOS sensors. Our first sensor is CCD. With the appearance of semiconductors, the first CCD sensors appeared in the 1970s, and the advances made in physics of solids as much as electronics have made it possible to have simpler and simpler and more efficient manufacturing process. The technology on which CCD sensors are based is the MOS capacitor. If a photon whose energy exceeds the energy of the gap is absorbed in the depletion zone, it creates an electron-hole pair. The electron remains in the depletion zone while the hole heads toward the earth electrode. The amount of negative charge that can be collected is proportional to the voltage applied, the oxide thickness, and the surface of the gate electrode. The total number of electrons that can be stored is called well capacity. The CCD register consists of series of gates. The handling of gate voltage is a systematic and sequential way transfers the electrons from one gate to another like a courier. For the charge transfer, depletion zones have to overlap each other. Depletion zones are in gradient, and gradients should overlap so that the charge transfer occurs. Each gate has its own control voltage that varies according to time. Voltage is a square wave signal called clock or clock signal. First, as you can see, a voltage is applied at gate 1 and photoelectrons are collected in the well 1. You can see it in figure B. When a voltage is applied at gate 2, electrons move toward well 2 like a waterfall in figure C. This process is fast and the charge is rapidly balanced between the two wells in figure D. When voltage is reduced at gate 1, the potential well decreases and all the electrons flow again cascading into well 2 in figure E. In the last figure, we can see when the voltage applied at gate 1 approaches 0 and all the electrons are in well 2. This process is repeated several times until the charge is transferred across to the shift register. When the gate voltage is low, it acts as a barrier, whereas when the voltage is high, the charge can be stored. The CCD matrix is a series of registers in columns. After exposure and charge generation by photoelectric effects for each pixel, the charge stored in lines or in the columns. By channel or arrested blocks and depletion zones overlap only in one direction. Charge transfer first occurs from line to line by intra and then inter-pixel gate jumps. At the end of each column, there is a horizontal pixel register. The register collects one line at a time and then transports the charge packets in serial mode to an output amplifier. The entire horizontal serial register has to be synchronized with the detection node before the next line enters the serial register. Our second sensor is GMOS sensor. A GMOS sensor is an image sensor that contains most of its functioning parts on a single circuit. It adds image to sensing capabilities to devices such as cell phone cameras and scanners and allows the user to convert a real-life scan into a digital image. A typical GMOS is an integrated circuit with an array of pixel sensors. Each pixel sensor contains its own light sensors and active amplifier. An analog-to-digital converter and other components critical to the operation of the pixel sensors are located on the CMOS sensor. Light comes to the lens and is processed by the color filter before reaching the pixel sensors array. When the filtered light reaches the pixel array, each pixel sensor converts the light into an amplified voltage signal that can be further processed by the rest of the CMOS sensor. The CMOS sensor contains four main parts. The first one is color filters. An array or a mosaic of thin color filters is placed over the pixel sensor array to capture color information. Each filter in an array corresponds to pixel sensor in the pixel array and only allows certain colors of light to pass to the pixel sensor. The second part is a pixel array. The pixel array consists of millions of active pixel sensors responsible for capturing the intensity of the filtered light passing through. Each individual pixel sensor then converts the detected intensity level into a voltage signal before passing it down to another part of the chip, such as analog to digital converter. The third part is a digital controller. The digital controller is a set of circuitry integrated on the CMOS sensor that controls the pixel array. It consists of multiple components including the clock, timing generator and oscillator to ensure that every pixel in the array is in sync with each other. It is responsible for telling the pixel array to when start capturing light. About our last part, analog to digital converter. It takes the analog voltage signal from the pixel sensor array and converts them into digital signal. The final digital signal is then outputted to an image processor or another device independent of the CMOS sensor, which converts or further processes the digital signal into something viewable by the end user. So we're gonna talk about how CMOS use that part and how CMOS use that part and how it's gonna work. When the pixel array receives the signal from the digital controller, the pixel sensors captures the intensity levels of the wavelength filtered lights and the output result as analog voltage signal. The analog signal is converted into digital by the analog to digital converter, so that the final signal leaving the CMOS sensor can be used and further processed by other digital components on the printed circuit board of the device. The size of the sensors is similar to the CCDs and can be close to a micrometer in some cases. One of the problems raised by the CMOS technology is the size of the sensors is similar to the CCDs and can be close to a micrometer in some cases. One of the problems raised by the CMOS technology is the loss in spatial resolution due to the presence of the amplifier A on photosites. This is shown up there. At first, only one transistor was used to amplify. Nowadays, these amplifiers can include 3 to 5 transistors and fill factors can be significantly diminished. Now you're gonna see a table which consists the comparison of CMOS and CCD. Now we're gonna see a table which consists the comparison of CMOS and CCD. Now we're gonna try to talk about the table. If we're gonna talk about the advantage of CCD, we can say these features. Despite improvement in CMOS, CCD still maintain an advantage, albeit a shrinking one, for applications that need the highest image quality in terms of uniformity, MTF, dynamic range, electronic shutter capability, and image stability. The caveat being, of course, that they must be able to operate acceptably at a CCD available speeds. I mean, state-of-the-art CCD cameras are limited at 160 megapixels per second. Faster is possible, but only at significantly higher cost, camera size, and power. In addition, the dark current of the best CCD sensors is still better than CMOS sensors. And last one is CCD has traditionally offered higher dynamic range and higher resolution. But on the other hand, CCD has some disadvantages like CCD frame rates are slower, they require more power dissipation, and they cost more to manufacture and integrate than CMOS. CCD sensors are using dedicated processes with a much slower innovation cycle. So how about advantages and disadvantages of GMOS sensors? Recently, GMOS sensors have shown significant improvements in quality. Now, in addition to higher speed performance, lower power requirement, and higher integration potential of GMOS sensor resolutions and data quality are approaching those of CCD sensors. Also, the speed of developments in GMOS is faster since it's produced in non-dedicated fabs. So sensors prototypes can be developed and incorporated in cameras faster. Fast GMOS enable improvement in throughput that are far superior to CCD and critical to the requirements of applications such as in semiconductor and PCB inspection. Combined with the relative ease and cost effectiveness of GMOS manufacturing, which uses much more widely available production capacity, GMOS is most preferred sensor in nowadays. GMOS sensors are closing the gap in noise level, an area where CCD used to be clearly superior. But like CCD, GMOS sensors have some disadvantages. For example, GMOS sensors also have more problems with optical crosstalk due to the thicker stack on top of the pixels. This results in a lower accurate color reproduction, especially with small pixels. And while the dynamic range of GMOS But like CCD, GMOS sensors have some disadvantages. For example, GMOS sensors also have more problems with optical crosstalk due to the thicker stack on top of the pixel. This results in a lower accurate color reproduction, especially with small pixels. And while the dynamic range of GMOS sensors with a rolling shutter and in-pixel CDS can be higher than CCD sensors with the same pixel size, the rate noise of previous generation GMOS sensors is much higher than that of CCD. This results in a lower sensitivity dynamic range. How does capsule endoscopy work? Capsule is initially stored in a case containing a magnet that inhibits capsule activation. Once it's taken out of the case, let's start flash. How does capsule endoscopy work? Capsule is initially stored in a case containing a magnet that inhibits capsule activation. Once it's taken out of the case, the LEDs start to flash and the capsules start to transmit. 8 aerial leads that are attached around the patient's abdomen collect data. Capsule ingested as any other capsule. Patient's can drink clears immediately, but no solid food for 3 hours. Attached to the leads is the recorder, and the patient should report back if it stops recording for any reason. Belt and aerial should be worn for 8 hours after swallowing or until the recorder stops recording. Recorder How does capsule endoscopy work? Capsule is initially stored in a case containing a magnet that inhibits capsule activation. Once it's taken out of the case, the LEDs start to flash and the capsules start to transmit. 8 aerial leads that are attached around the patient's abdomen collect data. Capsule ingested as any other capsule. Patient's can drink clears immediately, but no solid food for 3 hours. Attached to the leads is the recorder, and the patient should report back if it stops recording for any reason. Belt and aerial should be worn for 8 hours after swallowing or until the recorder stops recording. Recorder and aerial are returned, but the capsule is disposable. Images are downloaded and processed prior to interpretation.
Actually, we see mom because it's aiming towards mom.
Oh my god.
So she's waving.
It's filming
over there.
her right now?
It's filming her right now.
Okay.
So, all right.
Easy. Okay. Is there a trick to it?
I actually recommend that once you get it in and get your mouth full with water, tip your chin down because it'll
Down.
float to the back.
Okay. I thought it like
It's
up.
capsule. It'll float to the back. So.
Okay.
The nerves.
Yeah.
You're just having your favorite breakfast something and you're
Okay.
swallowing it down. So.
Oh my god, I did it.
That's your esophagus.
Oh my god. Look. Can you put the camera down?
That's your esophagus. We're not to the stomach yet. It's hanging out in your
word.
esophagus yet. Oh my god.
Can you see that? Is it supposed to be laggy like that?
Some people, that means when you swallow food, your esophagus tends to hang out with food for a little bit until the sphincter opens up and lets the capsule through into your stomach. Sometimes it requires drinking, meaning the capsule's still right about here. So
But it went down though. I was shaking.
So that's your sphincter opening and closing, saying, I'm not sure, that's not normal for me. You're not acting like it's food pushing more food on top of more food. So it will eventually just open up and let it through.
In this section, I will explain at which stage capsule endoscopy is used in a patient. Here we have a patient diagnosed with gastrointestinal bleeding. So what is gastrointestinal bleeding? These are bleeding in the digestive tract from mouth to rectum. So how does the doctor know that the bleeding occurs without testing? Blood can come from the patient's mouth. There may be bloody vomiting. Blood may come out of his stool. His stool may be jet black. After this situation, the doctor has two options: either gastroscopy or colonoscopy, and will learn the exact location of bleeding. If no bleeding is found as a result of this, it can perform gastroscopy once again, but the results may still be negative. Finally, the capsule refers to endoscopy method. Although in this method, the result of the bleeding may not be found and the source of the bleeding may not be found in a very small possibility. In this case, a second capsule endoscopy will be performed. As a result, the source of bleeding is located in a small intestine. Then push enteroscopy or double balloon enteroscopy is performed. In this part, double balloon enteroscopy is performed if permanent bleeding continues. Intraoperative endoscopy and supportive treatment can be performed. What are the advantages and disadvantages of capsule endoscopy? Advantages: painless, no side effects, miniature size, accurate, high quality images, efficient than X-ray, CT, and normal endoscopy, high sensitivity, avoids risk in sedation and radiation, simple procedure, and the harmless materials. Otherwise, disadvantages: patients with gastrointestinal structures or narrowing are not good candidates for this procedure due to risk of obstruction. Patients with pacemaker, pregnant women face difficulties. The pill will get stuck if there is a partial obstruction in small intestine. Impossible to control camera movement. And very expensive. Some of you may wonder the price. We asked the price of capsule endoscopy to many private hospitals in Turkey. An average of 12,000 Turkish lira. I said on the previous slides, in some case, capsule endoscopy is performed twice, so we may have spent our money for nothing. Advantages of capsule endoscopy over endoscopy and colonoscopy. In endoscopy and the colonoscopy, there is lots of wires we use, and it has a long tube to be inserted to the patient's body. But in capsule endoscopy, there is no need of wires and tubes. Patients may feel irritated on the insertion of the endoscope and colonoscopies through mouth and rectum. But in capsule endoscopy, there is no irritation because of its structure. And there is certain precautions to be taken while endoscopy and colonoscopy, like don't take solid food before the treatment. And there is no perceptions for capsule endoscopy rather than fastening. Very useful device. Its development is also difficult because considering the development of device, basically two things are considered. Firstly, can we direct the movement of the capsule? Secondly, can we get the capsule to take parts from the body biopsy. Yes, in the near future, capsule endoscopy is expected to have a positive impact on many aspects of gastrointestinal disease evaluation and management. Thus, the natural evaluation and the future of video capsule endoscopy points towards integrating mechanism for active locomotion and also providing the capsule with microsensors and the microtools for advanced diagnosis and therapy. The challenge of future research and development is to overcome the current limitations by improving the image quality and the frame rate, developing a very compact, high performance and the low powering camera module. Achieving this aim will pave the way to on-the-board integration of other submodules for localizations, biopsy and the stew treatments that may enhance the capsule performance. We will look at some prototypes that the capsule which has not yet been made is planned to be in the future. Firstly, Odo capsule. As the Odo capsule traverses through the small bubble, the wells turn and their rotations are translated to distance covered by the device from the point of duodenal entry to each area of the interest. Its main is to present the author's views on interesting current projects in capsule endoscopy and vision for potential convergence of various diagnostic platforms, drugs delivery capsule platforms. The use of the radiomakers allows determination of the capsule location. The aim of this device, when the holes align under the magnetic field, straining shape memory alloy wires, there is a release of the drugs. To date, limited information is available in the literature on the use of the capsule. There are lots of prototypes for capsule, but we chose just 3 of them. Finally, magnetically actuated soft capsule endoscope. Scientists design the rolling locomotion of a magnetically actuated soft capsule endoscope for diagnostic and therapeutic medical applications in the stomach. The aim of this device that is to provide a more complete view of the 3D stomach tissue wall, this reducing the possibility of missing problematic tissue areas of the stomach wall.
In the last part of our presentation, we got some questions to you for check what you learned. True false question. Question 1. Capsule endoscopy is using for detection of diseases of small intestine. It's true. Question 2. In capsule endoscopy, there is a CCD sensor. It's false. Question 3. Capsules are reusable devices. It's false. Question 4. Capsules can record videos. It's false. Question 5. Capsules endoscopy can be applied every adult people. In last part of our presentation, we got some questions to you for check what you learned. True false questions. Question 1. Capsule endoscopy is using for detection of diseases in small intestine. It's true. Question 2. In capsule endoscopy, there is a CCD sensor. It's false. Question 3. Capsules are reusable devices. It's false. Question 4. Capsules can record videos. It's false. Question 5. Capsule endoscopy can be applied every adult people. It's false. Question 1. Which is not part of the capsule endoscopy? It's D. CCD. Question 2. Which one is not the property of the capsule endoscopy? It's E. Optical dome is a conductive element of the capsule. Question 3. Which is not the advantage of the capsule endoscopy? It's E. Impossible to control camera behavior. Question 4. Which is not one of the properties of optical dome? It's C. Harmful. Thank you for listening us. Stay healthy. Have a good day.